Hello. Welcome to St. Mark Hospital. Our faculty has been working diligently to reevaluate the guidelines for our use of radioactive materials. This video covers the department that deals with the storage of radioactive materials, such as strontium-89, strontium-90, and all other radioactive isotopes of strontium.
Strontium-89 is a radiopharmaceutical, which is an agent used to treat and identify diseases and study the function of the body's organs. Strontium-89 is commonly used to treat bone pain associated with specific cancers such as prostate or breast cancer. Strontium-89 is taken up in the bone area of cancer, and the radiation provides relief.
There are two ways to store strontium in a hospital environment: the wet method and the dry method. The wet method involves the strontium being stored at the bottom of a pool, and the dry method involves it being stored beneath a concrete barrier.
Strontium chloride SR89, for example, is supplied in a 5 milliliter vial containing 148 mbq. The vial is shipped in a transportation shield container with a package insert and 2 therapeutic agent warning labels. The vial and its contents should be stored inside its transportation container at room temperature, which is 15 to 25 degrees Celsius or 59 to 77 degrees Fahrenheit. Some strontium being dry and or solid, this image is how the radioactive materials storage room should be designed. The strontium is placed underneath a concrete barrier and sits on a concrete pad. To ensure the strontium remains room temperature, there is a channel for cooling air.
On the other hand, when using the wet method, strontium is stored in double-walled stainless steel capsules. These capsules lie at the pit of a 13-foot pool that is also lined with stainless steel. This method is commonly used by the WSEF, the Waste Encapsulation and Storage Facility at Hansford. Strontium waste capsules go through a series of processes, such as converting it to strontium fluoride in preparation of being put into the large pool. These capsules are considered waste because the strontium capsules often include impurities such as barium, lead, and other inorganic materials from drying room surfaces.
Most non-radioactive strontium minerals, strontium compounds, and strontium-containing materials do not require special disposal and handling requirements. However, some chemical forms may be classified as hazardous materials if the compound is chemically reactive, flammable, or toxic. Radioactive strontium does require special disposal and handling requirements and is regulated by the Nuclear Regulatory Commission. Radioactive waste containing radioactive strontium can be grouped into 3 categories: low-level waste, high-level waste, and spent nuclear fuel.
The equations above represent radioactive decay that has occurred to strontium. In this particular photo, we start with strontium-87. The strontium-87 then gains a neutron and becomes strontium-88. A neutron causes the atomic number to decrease by 1. Then following the arrow downward, we see that strontium-88 then gains yet another neutron and becomes strontium-89. Now that we have strontium-89, we actually split to see 2 separate reactions occur. I'm actually going to start by explaining the radioactive decay to the left of the splitted arrow. Okay, so on the left, the strontium-89 gains an additional neutron and becomes strontium-90. I'm now going to explain the different reaction that occurred to the right of the splitted arrow. So, let's take a look. Okay, we see that strontium-89 actually gains a beta particle. Beta particles actually subtracts from the atomic number by an increment of 1. Therefore, strontium-89 is now yttrium-89.